All right, in question 7, it says aluminum metal can be recycled from scrap metal by melting the metal to evaporate impurities. Calculate the amount of heat needed to purify 1 mole of aluminum originally at 298 Kelvin by melting it. The melting point of aluminum is 933 Kelvin. The molar heat capacity of aluminum is 24, and the heat of fusion of aluminum is 10.7 kilojoules. All right, so I have 2 different things that I need to do. I need to take aluminum and I need to increase its temperature to 933. Once it's at 933, then it will melt, right? So you need the temperature, you need to increase the temperature to get it to the melting point, and then you actually need to melt it. So you're gonna have 2 different equations. One of them is your Q equals MC delta T, right? Now notice, you're not actually gonna be working with mass, you have moles, so you know that the heat capacity is 24 joules per mole Kelvin. So you're gonna take that and you're gonna simply multiply it by moles and multiply by temperature. So it's very similar to Q equals MC delta T, except since it's the molar heat capacity, the units are just different, okay? So you should get 15 kilojoules for that. Then I need to actually melt it. Well, the heat of fusion is 10.7 kilojoules per mole. And since I have 1 mole of aluminum, that means that the heat of fusion is just going to be 10.7. So I'm going to take 15, add 10.7 to it, and I get about 26 when I round. Okay, you get 1 point for calculating the amount of heat needed to raise the temperature to 933, and you got 1 point for calculating the heat of fusion. Okay, in B it says the equation for the overall process of extracting aluminum from aluminum oxide is shown below. Which requires less energy, recycling existing aluminum or extracting it? So we're going to compare A and B, okay? So for extracting aluminum ore, right, the heat required is 1,675 kilojoules per mole, okay? Per mole of reaction, okay? And so this is where it gets a tiny bit tricky. So you have 1,675 kilojoules mole per reaction, okay? I need to get into kilojoules just per mole of aluminum. So what you have to do is take kilojoules per mole of reaction, put moles of reaction on top to cancel that out, and then moles of aluminum on bottom. And the reason why this matters is because for every mole of reaction that occurs, 2 moles of aluminum are going to be produced. So it's going to be a 1-to-2 ratio. So you just got 837.5 kilojoules per mole of aluminum, which means that much more heat is needed to extract aluminum than simply to recycle. So recycling requires less energy, and you can explain that, you can justify your answer simply with your calculation. So you just have to show that 26 is less than 837.5, and that will work as an explanation.